does GDB look like in C++?
In C++, it doesn't look any different. But okay, it shouldn't be so quick. Let me show you. Let me show you what it means. So here I have a program, and by the way, if you want to pass arguments to it, you can do it like this. So you have a program, and so C++ is more difficult. For one, it's more difficult to set breakpoints because you need to try to formulate the function. The other thing that is somewhat more difficult is, let me see if I breakpoints are more difficult to set. I admit I don't even know how to do it. What you would see in if you look at stack traces in C++, you may be seeing lines like this one, and they can be very difficult to read. Other than that, there's nothing special, or I should say nothing. There is very little special about debugging C++ code. And the reason is because the C++ toolchain uses the same linker as the C toolchain. So all those names that use templates and overloaded functions and so on are reduced to simple symbols. In other words, the linker in the runtime environment knows almost nothing about the fact that we're running a C++ code. And similarly, you can use GDB to debug Fortran code. You can debug it. You can use it to debug any code that is compiled according to the conventions of the ABI application by interface on the platform. So in Linux, it's the System 5 release 4 ABI that's been used. GDB just needs to be able to get more information. GDB needs to be able to read symbolic information, which also follows the standard. And then if you compile with -G, then the compiler will add additional, even more symbolic information according to the standard called the Dwarf2 standard. And this allows the debugger then to examine the executable and extract the information of where certain local variables where variables can be found. Okay. So this mapping between addresses in the program or between offsets on the stack and symbolic values, that mapping is created by the compiler, stored as part of the dwarf information, and it's bundled with the executable. And GDB uses it. And so what that means is it can do that for any language that produces valid dwarf code. C, C++, Fortran, and so on. So in that sense, C++ is not special. The fact just that many functions are templated functions are difficult to read, and GDB does not help you with that, at least not to my knowledge. Maybe there are some other GUI tools that allow you to make better sense of these templated functions, but I will not be able. Other questions?
Can you use GDB to debug code that's written to use OpenMP or MPI?
So what if you have, the question is, what if you have special libraries that can GDB be used in those cases? The short answer I would say is yes. Okay, so these tools either have some special versions of GDB or some front ends to GDB that you can use. I think MPI has something like doesn't MPI have MPI GDB or yeah it's good. Yeah. So basically the way these work is because those tools will typically spawn multiple processes, and they then attach a debugger either to each of them, okay, or maybe just to one, or depending on. Sometimes when you write I've written multi-process code before, and I would typically add facility to run GDB in there. We have a little script that maybe starts 8 X terms and runs GDB in each of them. There's also a number of people do research in creating more scalable debuggers for parallel distributed systems. So just attaching multiple GDBs works for 2, 4, 8 processes. But if you go 16, or if you think of a blue gene machine with a million or so cores, that of course will not scale. There you need to use different tools. Okay. Are there any other questions? If not, thank you for coming. I hope it's useful.